Hello everyone, myself Vikas Kumar and I'm studying in Sri Venkateswara College of Engineering, 5th sem. My USN is 1VE22IS 060. The subject is Computer Networks and the topic is Point-to-Point Protocols. Introduction to Point-to-Point Protocols. Point-to-Point protocol is widely used communication protocol that enables direct connections between two network nodes. It provides a standard method for transporting multiple multi-protocol diagrams over point-to-point links. PPP is commonly used for dial-up, internet access, and broadband connections. It encapsulates network layer protocols like IP and sends them over serial or other point-to-point links. Its primary features include authentication, encryption, and compression. Unlike other protocols, PPP works over synchronous and asynchronous circuits and supports variety of network layers protocols, including IPv4, IPv6, IPX, and AppleTalk. History and development of PPP. PPP was developed in early 90s as a successor to Serial Line Internet Protocol (SLIP). SLIP lacked error detection, compression, and authentication, leading to need for more comprehensive protocol. The Internet Engineering Task Force (IETF) standardized PPP in RFC 1661. PPP revolutionized dial-up connections by allowing multiple network protocols to coexist, creating the foundation for later Internet protocols and broadband technologies. Triple P's flexibility and extensibility helped it to adapt to various link layer technologies beyond serial connections such as ISDN, DSL, and wireless links. Triple P architecture and components. Triple P has a modular architecture with three main components. First one, encapsulation, defines how to encapsulate network layer protocol data units (PDUs) into PPF frames for transmission. Link Control Protocol (LCP) establishes, configures, and tests the data link connection. LCP handles link establishment, termination, and negotiation of options. Third one, Network Control Protocol (NCPs). Each network layer protocol, such as IP, has its own NCP that negotiates configuration parameters specific to that protocol. Triple P's layered approach allows it to support multiple network protocols simultaneously. Triple P frame structure. A frame consists of several fields including a flag, identifies start and end of a frame, address defaulted to the broadcast address, control defaulted to 0x03, used for unnumbered frames. Protocol indicates the type of payload such as LCP, NCP, or IP. Payload, the encapsulated network layer protocol data. Frame check sequence, FCS, used for error detection. Triple P frames provide both link layer error detection and encapsulation, ensuring the data integrity during the transmission. Link Control Protocol (LCP). LCP is responsible for establishing, configuring, and testing the data link connection. It negotiates link options like maximum transition unit, MTU, authentication methods, and comprehensive techniques. LCP allows dynamic link configuration by adjusting parameters to optimize link performance. LCP packets are exchanged between nodes during link establishment phase and can handle link termination if errors are detected. Key features of LCP include error detection, loopback detection, link quality monitoring. Authentication in PPP. PPP supports two primary authentication protocols. First one, Password Authentication Protocol, also known as PAP, a simple two-way handshake mechanism that sends usernames and passwords in plain text. PAP is less secure due to lack of encryption. The second is Challenge Handshake Authentication Protocol, also known as CHAP, a more secure three-way handshake protocol that uses a shared secret and a hashing function. CHAP periodically verifies that identity of right through the session, reducing the risk of replay attacks. Authentication is critical in PPP connections, especially for securing remote access. Network Control Protocol (NCPS). NCPS are used to negotiate network layer protocol settings after the PPP link is established. Each protocol has its own NCP, such as IP Control Protocol (IPCP) for IPv4 and the IPv6 Control Protocol IPv6CP for IPv6. NCPs configure parameters such as IP addresses, compression technique, and encryption settings. Once the network layer configuration is complete, data can be transmitted between nodes. NCPs allow PPP to handle multiple network layer protocols simultaneously. Error detection and compression. PPP incorporates error detection through its frame check sequence FCS fields. The FCS uses cyclic redundancy check CRC to detect error in transmitted frames. If an error is detected, the frame is discarded and retransmitted. Triple P also supports compression protocols like Van Jacobson, TCP/IP header, compression to reduce the size of a data frame, improving bandwidth efficiency, error detection, and compression mechanisms enhances PPP's reliability and performance over slow or unreliable links. PPPoE, PPP over Ethernet. PPP over Ethernet extends PPP functionality over Ethernet networks, commonly used for DSL broadband connections. Triple PoE encapsulate Triple P frames within Ethernet frames, allowing ISPs to authenticate users, assigning IP address, and manage connections dynamically. Triple PoE enables session management and bandwidth allocation, making it ideal for broadband services where multiple users share a network. It also supports the same features as a standard Triple P, including encryption, compression, and authentication. PPP over other protocols, SLIP, HDLC. PPP offers significant advantages over SLIP and HDLC. Unlike SLIP, Triple P supports error detection, authentication, and uses multiple protocols. It also works over synchronous asynchronous links, while SLIP is limited to asynchronous serial connection. Compared to high-level data link control, which is used in point-to-point connections, point-to-point provides more flexibility, especially in authentication and compression. Point-to-point is widespread adaptation is due to its extensive feature set and compatibility across various networks. Point-to-point protocol applications and use cases. Point-to-point protocol is used in several applications including dial-up internet access. Point-to-point protocol was standard protocol for modems and dial-up connections, enabling the internet access through ISPs, VPNs. Point-to-point protocol combined with tunneling protocols like PPTP provides secure connection for virtual private networks, VPNs. Broadband connections, PPP over E and PPPoA, PPP point-to-point protocol over ATM are widely used in DSL and fiber broadband services. Embedded systems. Point-to-point protocol is also used in embedded system for serial communication between devices. Its versatility makes it suitable for various network scenarios. Future of point-to-point protocols. While point-to-point has been widely replaced by newer technologies in modern networks, it remains relevant in certain niche applications. It uses legacy systems, embedded devices, and DSL networks. Ensures that point-to-point protocols will continue to play a role in specific industry as broadband technologies evolving. Point-to-point, point-to-point over point-to-point protocol over Ethernet and similar encapsulation methods may still be utilized, and additionally point-to-point protocols principle of flexibility, extensionability, and multiple protocol support will influence future development in networking protocols and techniques. Thank you.